Hail is a solid form of precipitation which causes roughly $125 million worth of damage to cars per year. Assessing this damage manually takes up to 30 minutes per car and is a very tedious process. Our sponsor, Ally Financial, is a major automotive insurance provider that insures automotive dealership lots. They tasked us to create a robust and mobile system which can be transported from dealership to dealership to automate the process of assessing damage caused by hail to cars. We chose distortion imaging to be our method of choice and designed a rig with a lighting and imaging panel installed on a PVC linear rail. The rig is 102 inches wide and 100 inches tall to accommodate almost every standard production car. The lighting panel is made up of two shop lights which houses two fluorescent light bulbs each, with a diffuser and a striped pattern overlaid on it. On top of the shop lights, there is a Raspberry Pi and a Pi camera, which are used for image acquisition. Data is collected by roughly taking 23 pictures of each panel of the car. This is done by sliding the imaging apparatus along the rail and using the Raspberry Pi to control the camera. The height of the linear rail can be adjusted using sliders on the side of the rig. Once image acquisition is complete, the images need to be processed. The projected pattern with the distortions created due to dents can be seen in this image. The image is first normalized to negate the effects of uneven light intensity and is then binarized. A shape extraction method is used to extract all horizontal structural elements. This is then subtracted from the binarized image to obtain the distortions without the stripe pattern. To denoise this image, the image is superimposed upon itself after moving it upwards by roughly 3 pixels. A Gaussian blur is used to cluster the distortions, and then the image is sharpened to improve the contrast ratio of the blurred image. A labeling function identifies each distortion and classifies it as a dent. The software then creates a bounding box on each dent and overlays it on the original image to enable the user to verify the accuracy of the program. We created a graphical user interface to simplify this process for an average user. The raw images captured by the rig first need to be stitched together to create a singular image for each panel. The background of this image needs to be cropped out to minimize disturbances. Here is a live demonstration of our graphical user interface.